Hi guys, welcome to class. So let's consider some important bacteria. Now this in the sense that we have known how to classify them. So that means that if you look at the bacteria and I ask you what's the classification of this bacteria, or ask you that what's the criteria I'll use in classifying this bacteria, you have to tell me this bacteria can be classified based on shape, and by based on shape I mean you're going to tell me that it can either be a cocci, spherical, it can be a bacilli, rod shape, it can be a spirille, or it can be a vibro, curve shape. And based on use of oxygen, you're going to tell me it's either going to be an obligate aerobe, a facultative anaerobe, an obligate anaerobe, or a microaerophile. And based on gram staining technique, you are going to tell me it's going to be a gram negative or a gram positive, basically. Now, let's look at this. Mycobacterium. This is a genus of bacteria, Mycobacterium, and this genus of bacteria consists of species that are similar in structure to the fungi, because the fungi basically they are known for forming these branching structures. Formation of this branching structure, they call it hyphae, similar to fungi. Basically, that's what I'm saying. Similar to fungi, continuously form branching, and they are gram variable in the sense that when they go through gram staining technique, you don't know whether they are gram positive or gram negative, because they will just be colorless. They don't give any change, whether pink or purple. So we refer to those bacteria as gram variable. They are rod-shaped. And then an important species under this genus is and they're aerobic as well. They're aerobic. Now a very important species under this is Microbacterium tuberculosis. That's the causative oxygen of your TB. Do you understand? Yeah. So we just ran through Mycobacterium. So we can classify it as bacilli, rod-shaped, aerobic in terms of oxygen use. Gram variable. Yeah, there you go. Alright. Now let's look at mycoplasma. Okay, mycoplasma. How about you? Well, similar to Microbacterium, it also forms continuous branching. It branches continuously. So it branches continuously, basically forming branching. So it branches continuously. Similar to Microbacterium, again, it is gram variable. It's spherical in shape, spherical rod shape, aerobic as well. Aerobic. Now, one unique thing about it is that it lacks a cell wall. Mycoplasma lacks a cell wall, and that's why it's not even stained. And that's why it's gram variable. So it lacks a cell wall, but it's structurally resistant to lysis. Very well, right? Well, that makes it special. It lacks a cell wall, and it is structurally resistant to lysis. How about nitrogen fixing bacteria? I mean, if you have never known anything about bacteria, you must have come across this guy. Everybody likes to describe nitrogen cycle. It's quite an interesting nutrient cycle. Or you don't agree? No. Everybody has their choices. Nitrogen fixing bacteria. There you go. Now, it has the ability to convert atmospheric nitrogen. It has the ability to convert atmospheric nitrogen to ammonium compounds. Okay. Now, gram negative is not gram variable, it's gram negative. It's rod shaped, that means the bacilli. It's also aerobic. Finally, it's also aerobic. Now, a very common genus under this group of bacteria is the Azotobacter. So, you notice when we're going through these bacteria, you look at how we're defining, how we're classifying them, describing them, telling us if it's gram negative or gram positive, if it's aerobic, if it's anaerobic, is it facultative, or is it a microaerophile. Also, in terms of shape, you see cocci, is it bacilli, is it vibro. That's basically how you describe bacteria. See you in the next class.